Hi everyone, thanks for coming. We're all software developers, and all of our software development is a continuous cost-benefit analysis. We have to work out what the input is and the amount of effort that we're going to put into writing a piece of software and what the benefit is that we're going to get in return. And so today I want to talk to you about the Arrange Act Assert pattern, and really my goal is to show you that, I'm not going to deny there's a cost involved, but I want to show you that hopefully there's a great benefit. So what we're going to talk about today, well firstly, I'm going to give you a bit of background about me and how I found the pattern, and some givens about, to kind of make sure that our opinions about where we're at tally. And then we're going to talk a bit about the problem as I see it in terms of some of the issues that we're experiencing in unit testing. We're going to look at the pattern itself and a couple of smells and solutions, not as many as I wanted to fit in. So if you're having trouble with Arrange Act Assert, come and grab me afterwards. And then I'll take questions after the break because I've really rammed a load of stuff into this talk. So, background. I've been a Python developer for 5 years. I've been doing TDD in a Kent-Beck kind of way for about 4.5 years, and I've been using the Arrange Act Assert pattern for 2.5. I was introduced... my introduction to AA has some negative around it. I had a pull request rejected at review by the lead developer in the team, whose name is Carlos, and he lives on GitHub here. And he said basically your tests are hard to read. I'm not understanding what the action is. Please, and he said basically please use Arrange Act Assert. And about a month ago I was like, can I get this repo back and maybe resurrect that and show you it, because I'd be able to show you my horrendous test. But they'd wiped it, so it's gone. I felt really bad. So at first I thought to myself, well, my tests are good enough, why should I have to change it? But actually, working with the pattern has helped me going forward, and I use it all the time, and hopefully I can share that benefit with you. So let's talk about some givens. We all love PEP8. It creates uniformity and is valuable for code collaboration. I think it's excellent for long-standing code. It keeps things pinned in terms of linting. We also love PEP20, it's in Python. Two key things that we're going to talk about today: explicit is better than implicit, and readability counts. Of course, everyone does TDD all the time. We are going to use, I'm going to use just test functions, decoupled, they could run in any order, and I'm not going to talk about particular, or as little as possible, about testing frameworks. I'm just going to keep it really simple. We want simplicity over performance. So I actually was going to talk to you about this, but Brandon said it in the keynote on Friday, and I wrote it down. Taking a few percent hit, going a little slower to do something fundamentally simpler. He said it better than I could. And finally, we're going to try and eliminate duplication. That's a smell we should be avoiding. Right. So what's the problem as far as my experience and how I see it? We work so hard to write Pythonic code and make everything clean, as easy to read as possible, and we open the test suite and the test suite is carnage. That strikes me as bad, and I call it the restaurant kitchen problem. Have you ever had the problem? The thing, you go and you get dinner from a kitchen or restaurant, and it's beautiful, lovely food, and you say, excuse me, where's the toilet? And they say, it's just past the kitchen, and you walk past the kitchen and you think, geez, that kitchen is worse than mine after I haven't cleaned it for a week. And I think it's so important that the space in which we work is clean and healthy and easy for us to operate in. The number of greenfield projects we work on is decreasing. That's my feeling. It may be different for you, but we're often taking over code and looking after test suites. And importantly, in open source software, we are contributing to code. Very often, the requirements of making contribution are that we write a failing test first, and so we go and crack open the test suite. And it can be written very differently to the library. It's often not shipped with the library, and that can be very challenging. So it slows us down, we have to context switch, and that is effectively, I believe, hurting our community. So in this, I'm going to talk about a few examples. This is the worst OML style diagram I've ever made. I'm going to do some very simple account member stuff, and this is just to prime your minds. Let's look at the pattern. It's also known as AAA and 3A, so it's actually quite fine. I found it quite challenging to look this up. There's some but it's very simple. So you only need one pointer to explain what a pattern is. Effectively, every test we have a function definition. We have a docstring. We arrange, which means a block of code that sets up the state for our test. We do some form of action and some form of assertion, and there are two white space lines, one before the act and one before the assert, and that is the pattern. So let's build an example and flow through that just so we can see how that works. We're going to test that every member has a principal name, and I'm just going to flow through that. I'm not going to look at any front-side code, we're just going to experiment with what that looks like. So let's drop in a function definition, a test for the principal name. Let's look at how we build a docstring. So what I'm looking for in a docstring is a style that matches the front-side library. So whatever your tech lead has decided, the style, or you've decided on your OSS project, maintain that style. It maintains consistency. Personally, I like the Google style guide for Python docstrings. There's a link to that at the end. I'll show you that. And I believe that actually every docstring in a test should have a positive statement. What does that mean? Don't use should or would. That's not a very positive statement. We should avoid using do or would. So when you read a test, that says, in fact I saw one the other day, the view should return X. Well, is that a to-do? Is that some code that needs fixing? The view should return X? That sounds like a criticism. So why don't we change it into what it does? What I recommend is that we say X given Y does Z. And the reason that I state that is because X is the module we're testing. We say given Y tells us about the state, and Z tells us about the action we're expecting. And what's really helpful is a lot of test runners extract that first line of your docstring, and they put OK or fail on it as they run through. So you get the opportunity to say, X given Y does Z, OK. A given B does C, OK. And it's really helpful when you see that come out. So think about what you want to see coming out of your runner, and I avoid punctuation. This is the opportunity to lift extra info about your test conditions into the docstring. You can pad it out, you can write it as long as you want. I think it's helpful. I'll show you a little state markdown table. I sometimes, for more complicated setups, write more stuff. So let's drop in our docstring. New members have principal names. Positive statement. Next thing, let's look at arrange. Arrange is a single block of code with no new lines. No blank white lines. It obviously has new lines at the end. We're looking for no assertions in our arrange blocks. And what I would say about that is we're just setting up code, and ideally we don't want tests to break at arrange time. What we want failures to occur is when we're making assertions in our assert block, and what we want ideally is that any situations where an arrange fails is because of some other side effect somewhere else. That is those two things. That's really the arrange block. What I'm about to say are kind of the weird things about arrange blocks, which people have their own flavours about it. I believe that we should only prepare non-deterministic results not available after the action in the arrange block. So one example is, let's say we were deleting one of our members and all members had UUIDs. If we want to check after the deletion that the UUID is gone, it's going to be hard to recreate that after we've made the action and delete the user. So that would be an example of keeping a result that we need for later. And the reason that we push that result calculation later is it's going to help us when we dry out our code and actually want to keep our test clean. So the more opportunity we have to dry out refactor, the better. And this is, it shouldn't require comments. Everything here should be easy to read. If there's complications, like I said, we can lift it to the docstring, and we're really looking for that block of code that's really intelligible. And it's an optional block, but in this case, let's wire it in. So let's get into the arrange here. We want a new person, a new member, we'll stash it inside person. Let's give them a first name. Renee is one of my favourite test names. Nice, E and Q. A lovely surname, Beijing. Obviously, you all recognise that. And that is our arrangement. So let's look at action. Act should always, in my opinion, use a result equals star format. And the reason that I say that is that when you use that everywhere, your eye goes to it so quickly. If everyone in your team is using result equals, it makes it really quick and easy to find the place in your test that has failed. I expect every act block to be one line only. As soon as you're taking it, if you write a test that has a two-line action, think to yourself, what am I testing? Is it that it's log in and then do something? So is log in arrange, or is log in part of your test? When you split that out and say it's one line only, it makes it easier. And like we said, it's surrounded by white space. There's one example that we would change or allow us to break is raising exceptions. We would kind of allow that to be a two-line action. And some people say to me, well, James, if I'm testing a function that has no result, why should I do result equals? So we know from Zen and Python that explicit is better than implicit. So if you have a function that returns nothing, it returns none. And actually, I would say you should do result equals, and you should be, your first assertion is that your result is none. And I believe that nothing is something, which is something that Sandy Metz has really got into me, who talks a lot about Ruby. I would say you should pin that non-result and make it really strong. So let's wire in our action here. We're going to, because we're testing the printable name for a person, we're going to do result equals person printable name. Straight on, let's look at the assertion block. Again, it's a single block with no new lines, and what we ideally want to do here is as little work as possible to ensure that our result is correct, and we ideally want to limit actions. So take, for example, something where you've just done a test to store something in a database. If you're now going to go back and read the database multiple times, you're going to have to be careful of side effects. You might affect a read count, or you might affect some kind of stability, or side effects are one of the most difficult things to manage during testing. Like I said, non-deterministic results can be calculated, but again, be careful of your side effects that may pop up. I'd like to use an order in my assertions, and a little bit like I sort, but the other way around. So when you sort your imports, you very often import from standard lib, then you import third parties, then you import your own code. It's like kind of the I sort way. So I do the upside down, the opposite in my assertions. So we test the result first that we've just calculated, then side effects kind of getting further and further away from you as you read down the code. Again, by using that format, your mind goes, you expect that result first kind of process every time. And use simple blocks of assertions. And what I mean by that is when you notice that you continue to calculate the same results and assert them in the same way, it's a good smell to say, look, here's an opportunity to use an assertion helper, or to do something that makes it more easy and readable so that anyone picking up these tests will understand them. And again, we shouldn't really require comments because we want it to be really simple and understandable. So let's wire an assert block in here. I think it's going to be one line. Assert, we did a printable name, with a last name, comma, first name. So very simple assertion. The result should be Beijing, comma, Renee. So this is a super basic example, but it totally fits the pattern of Arrange Act Assert. And so what we're going to do, I just want to explore some of the smells that come up that can happen when you're trying to refactor some tests to be a little bit cleaner. So some of these smells affected me rewiring my first PR to fit this pattern. So one of the most common smells that I see is that projects that I've worked on and in open source software have assertions before the action takes place. So let's build an example, let's look at an example and see what we can do about it. We're going to look at testing a list of a members' accounts. So we're going to have a test for the account list for a member. We're going to have docstring that says members can list their accounts. We've got a nice arrange block with a sneaky assertion on the end. The action is that we want to grab the account list for a person, and then we want to make some assertions about it. The assertions aren't great; they're there. But this is key smell. So what we want to deal with is the assertion hanging on the bottom of our arrangement there. So let's use copy, and we're going to pull out that code block. So we're going to copy it. So we're going to create some duplication down the line, but there's some benefit coming. So when we pull that out, what this looks like, look at that assertion there. Assert person in. Let's take account.members and make that a result. So result is account.members. Let's patch that in there. So we've now got assert person in result. If we pad that result, so if you remember, the action should have a clear white line before and after. Now we've got something that starts to look like its own test. We can add a test definition. So let's test the account member setup. Let's add a docstring to describe to people what this test is doing. Members can join an account. And this now is a standalone test. I'm going to move this up, and let's bring back the previous code. So now we have an opportunity to say that assertion that was tagged on the end of the arrangement can be removed. Now, we've got a different problem. We've got duplication. And we can resolve duplication really easily with extract method. So let's pull that method out. Yes, we promised. Yes, I know. We promised ourselves to duplicate duplication. That was a reminder. Right. So when we extract this method, we can turn it into a function. So let's explore how that's going to go. If these three lines are going to become a function, we need a return. So let's send back person and account tuple. And to me, this code looks like a factory. That's what I'm seeing there. We're building a person, we're building an account, we're returning them. Well, we're joining that person into the account, and then we're returning them. So let's roll with that. Let's make this a factory. We call it account member factory, and we'll add a docstring just like a normal function. Create a member and account pair, and I'm just going to shuffle these three round for clarity. There's our test at the top left, the factory's on the right, and our original test bottom left. So what the next step of extract method is that now we wire this function call back into our test. So there's the use of the factory in the first test, and now let's wire it into the second test. So what have we ended up with? We've got two tests on the left-hand side. They're both using our new factory code that we've extracted. And what you'll notice is that the test in the top left-hand side is directly testing what our arrange code, which we've now encapsulated in the factory. So since that top left test is just testing our factory, that pair becomes really valuable. So let's rename that top left test. We're going to name it the test account member factory. Right? So, and we need to update the docstring. Sorry, let's update that. Again, positive statement about what we're testing. The factory generates the pair. So, what have we got at this stage? A docstring. It looks long, but it's 64 characters. What did we start with? We started with a test that had too many assertions. We had that assertion hanging on the end of the act block, and so with Arrange Act Assert, that's a smell. So what we did was we extracted that. We haven't removed any assertions. In the original example, we had 3 assertions. We had the hanging one, and that has just become its own standalone test. The smell, when you have that extra assertion before you take any action, It's a smell that there's too much happening in your arrangement, and that maybe you don't trust your arrangement. Maybe there's some code going on there that you really need to assert is doing what you think it is. We get some benefits here. So we get a new factory. We end up with 2 tests where, yes, we originally had 1, and the cost is that we maintain this factory with its standalone test. But the benefit is that we have a factory, and that we're going to use this moving forwards. And the second benefit is that we have 2 simpler tests that meet the pattern and make it easier for people who are opening up our test suite to understand where we're coming from. Now, Bill Way, who coined the term Arrange Act Assert, says that it's okay to blend the assertions and keep them there, and that you should make your decision about it. But I think that there's actually benefit in kind of extracting them where you can. But there's another problem hanging here, which is we've still got duplication. Person and count pair is generated in both parts, and we haven't spoken about what happens when we have duplication between tests. So let's explore that. That's the duplication. So when we have tests that are having multiple arrangements, we want to be able to eliminate that duplication. So for this, we're going to use 3 accounts with 3 members, but what we're going to do is we're going to let member B join account A. We want to do some tests around this scenario. We want to make sure that A can transfer to member B through that account number 1, but we want to make sure that A can't transfer to member C, and that C can't transfer to member A because it hasn't got a shared common account. And so that's 3 tests, and they're going to have the same arrange block. But we don't want that to be duplicated. So let's build this example. We're going to test the transfer between A and B with a docstring, an arrangement that sets up the accounts and adds B extra. We're using our factory that we generated earlier. And then there would be the act block, and there would be the assert block. So I'm being a bit naughty here. We should really write our assertions first, not the arrange part. But I'm just trying to show you the commonalities in range. We're going to have a second test with actually the same arrangement, a different action, a different assertion, and the third test as well, because we want to test these different cases. So extract method isn't good in this situation. What we're going to get back to is either a factory that's just for this specific case, and it's not generic enough to be reusable, but XUnit and test case in Python give us the opportunity to extract a setup. So I'm going to go through what we do in the test case example and how we use setup. So, I didn't realise, I resized the font. Those sit on top of the duplication, just believe me. So what we do is we're going to wrap this in a class so that we can use test cases setup. We add self to the functions, and we're going to make some room for a setup. So I made a small, because setup's not in Arrange Act Assert, I made some small rules about it. It's basically the pure arrange block extracted into the setup function. We want a docstring again, only if we need it. It should be readable, but there might be some complications. And I sometimes test that my setup is correct by writing a special function just for that job. So let's populate that now with what we expect. So here's an example where I've documented my setup to make it really easy for someone to read it just straight off the cuff. And we extract the arrangement from the test into the setup. And now we can eliminate those arrangements from the other 3 tests. And because this is a complicated setup, we should also test it. So I drop in the extra test here. And I put in the test exactly for the 3 lines that we have above in the docstring. Again, this time it's also a really simple block. It's a pure assert block, it has docstring if required, and we wire those in. So what does this give us? A really simple test suite that we have. Our arrangement is tested, it has its own test for that arrangement, and now we've got space to wire in the test cases around whether A can transfer to B and stuff like that. We have the space to go on and wire in the test below, simpler and clearer than they had been before. So let me give you a summary of where we got to. I showed you the Arrange Act Assert pattern as simply as we could. It's like paper for tests. Showing you a very small example. We've opened the door to drying out our test by applying it when we had some smells, when things didn't fit. And thanks for listening. The resources are online here. I've tweeted it on top of my Twitter account at James Pablo. Come and ask me questions in the break. Let's talk about testing, and thank you for listening.
We have no time for questions, so like I said, can go and ask questions in the break, and give another hand for James.